Okay, in order to create this histogram, we're going to graph a bar plot. So we're going to graph a bar plot with summary because we don't have actual counts, we have percents. The categories are in our variable 1, the counts are in our variable 2, and we actually have relative frequency, which I'm just going to go ahead and mark. You don't have to have it, but it's nice. And then we click compute, and here's the distribution that matches. Now we want to know the expected number of eggs we should find and the variance of that. Well, this information is not shown here, so we actually need to calculate using a custom calculator. We're going to close, and we're going to stat calculators. At the very bottom, you want to click custom, where our values are in variable 1, and our weights are in variable 2, and then we click compute. And so here gives the actual same distribution that you had in bar plots, but we also have down, if you scroll just a little bit lower, you'll see the mean is 2.6 and the standard deviation is 1.74. And you actually have the ability to calculate the probability of being less than or greater than, something like that. So the range of typical number of eggs that you would find in the nest is between what values? So what would you expect to have happen? We're going to be building our values of typical, I would say a 95% confidence interval. That's something that we haven't talked about before, but we want to think about, I would say, how many eggs would you think would be normal on average? Well, we're going to use this mean and standard deviation. Let's go back to our notes. Our range of typical values, this is given at the bottom of the page on page 98. Remember, it recalls back that we can use a standard deviation. We can take the mean minus 1 times the standard deviation and the mean plus 1 times the standard deviation to get this range of typical values. If we take 2.6 minus 1.746, we're going to get 0.854. And if we do 2.6 plus 1.746, we get 4.346. Now, you're not going to have decimal eggs. You're going to say between, like, that would be this range here of typical values. And the other ones would not be typical because 0 is not included in that interval and 5 and 6 aren't either. And again, there's formulas for these, but we're not getting bogged down by them because we used StatCrunch. Since we already put the data into StatCrunch, let's see how StatCrunch can help us find some probabilities. What's the probability of finding less than 4 eggs? The probability of finding it, this doesn't have a question here. It just says eggs, and the probability of finding less than 6 eggs. We're going to use StatCrunch to help. Here was our distribution. Now at the bottom, we have our mean and our standard deviation, and the question asks, what's the probability of finding less than 4 eggs? So I'm going to change this 3 to 4, and I'm going to change my symbol to less than, and click compute, and it tells me it's 0.65. And notice that all of the eggs that are less than 4 are in red. Less than 6 eggs, I can change that 4 to a 6, and StatCrunch tells us that that's a 95% chance because only having 6 eggs is the complement. So 1 minus 0.05 gives us that 0.95. Here are all the values that are less than 4. If you add those up, 25, 40, 50, 60, that gives us our 60% that StatCrunch calculated for us here. All right, now lastly, the mean of each probability distribution pictured here is 5. So here's the average, here's the average, here's the average, here's the average. Which one has the largest standard deviation? Well, remember, standard deviation is how far on average each point is from the middle. Now, D here has a very large peak at the mean, which means that there's a lot of values in here. That means that this one would have the smallest standard deviation, because it's not very spread out. There's not a lot of data outside. This peak is a little bit smaller. I would say that this is the second smallest. And then our next peak for B, so that means that I would say that graph A has the largest standard deviation. That is it for Module 15. We're moving on to 16 next.